did you miss class today? Did you miss something on the notes and you just want to see it again? We did something new today. This was Arithmetic Series. There's a difference between a sequence and a series, and today we did series, okay? All right, let's get everything ready. We'll take a little bit of notes and then do some problems. It was a really short, easy lesson. So, all right. Basically, we started out talking about what the difference was. Again, just as a reminder, the difference is between a sequence and a series. Remember that a sequence is just a set of numbers. Okay, there's probably going to be a pattern, but there's definitely a set of numbers. What we did a couple of days ago, depending on what class that you're actually in, is we found formulas for them. We found explicit formulas for them. And we're actually going to do an example here in a minute. But a sequence is just the set of numbers. An arithmetic series is the sum of that sequence, okay? And so it's taking that sequence and adding all of those digits up, okay? Let's actually go through a quick example. So the first thing I want to know is, knowing some of the information that I'm writing down, can we, that should be an N, sorry, can we actually write out this sequence? And so if I told you that A sub 1 is 1, the difference was 5, and the N is 10, can you write out that sequence? So what is the set of numbers that fits this info, okay? So let's go do that. So A sub 1 means it's the first term. So the first term in the sequence is 1. My difference is 5. So that means I'm going to be adding 5 every time. So if I add 5 to this, I'm going to get 6. If I add 5, I get 11, 16, 21, 26. But I need to stop when I get to the 10th term. That should be a 10, okay? So let's see. Let me count. Let's see where I'm at, right? So 1, 2, 3, 4, 5, 6. All right. 7, 8, 9, 10, right? Okay. Okay, yes. So there we go. So here's my sequence, right? A sub 1 is 1. My first term is 1. The difference is 5. I'm adding 5 every time, and there are 10 terms. So A sub 10 is down here. So let's go do this, what I had mentioned earlier. Let's go find that explicit formula, right? So a couple of days ago, the formula of the day was this. And so using this formula, using this sequence and the information up here, we're going to write the explicit formula for it. So any given term in the sequence. So I want that N to be there. I'm not finding the 10th term. I already know what the 10th term is. I want the formula that fits the sequence of numbers, okay? So using this formula, the difference was 5. I'm going to do N minus 1, and then I'm going to add the first term. The first term was a 1. Now, hopefully, you have done the next step, which is to clean this formula up, right? So you want to distribute, you want to combine like terms and all of that kind of stuff, okay? So this explicit formula should be, if I distribute, I'm going to get 5n minus 5 plus 1. Just putting some chicken scratch over here. So 5n minus 4. This is the explicit formula. Okay, it's not a recursive formula. So yeah, the recursive formula says that you take the term in front of it and add 5. The term in front of it and add 5. The term in front of it, right? That's a recursive formula. The explicit formula says, look, if I want that 10th term, I plug in a 10. Okay, so 50 minus 4 is that 46. That's what the explicit formula tells you. Okay, now what I want to do is I actually want to find the sum of this particular sequence, okay, the sum, which by the way is also known as the series. Okay, so what I want you to do right now is I want you to very quickly pause this video, and I want you to go add up all of these terms and see what you get. Okay, so pause the video and add them up. All right, so I'm hoping when you added it up, you got a 235. Now, one of the things that you can do is you can literally pick up your calculator and type in 1 plus 6 plus 11 plus 21 plus 16 plus, right? And you can go. And I don't know if you noticed, even when I said it out loud, I skipped a number, okay? The other thing that you, which is what sometimes happens when you try to do them individually. I did show you last week kind of a shortcut or a think smarter, work harder type of deal that could potentially help a little bit. And so that's what I'm going to actually do right now and show you the work smarter, not harder. So when I added this up, I actually did 46 plus 1, which is 47. And then I did 41 and 6, which is 47. 36 and 11 is another 47. 31 and 16, 26 and 21. So I have 5 47s. So I just multiplied. So if you type into your calculator 47 times 5, you'll also get 235. By the way, this chicken scratch that I kind of put on there is exactly where the formula came for evaluating an arithmetic sequence, and that's what I'm about to give you right now. Okay, this particular example, this is what it's going to look like today. So there's another sigma, right? Sigma notation, remember, is to add. You find the sum of the series. So this particular example looks like this. Okay, starting with the first term, ending with the 10th term, and then next to the sigma notation goes the explicit formula, okay? So this example, this is what it looks like. Now, last week, you were supposed to actually write it out, write it all the way out, put all the little plus signs in there, and then add it up. And how you decided to add it up was up to you. Today, there's a formula for it, okay? Again, this only works if there is an arithmetic sequence. So this is the arithmetic series formula, okay? And it says that what you're going to do is you're going to take however many terms there are, okay? This particular example, that number would be a 10. There were 10 terms. You're going to multiply that number by the first term plus the last term, and then you're going to divide by 2. Okay, so if I were to do that with this series, I would, my n is 10, so I'm going to do 10 times a sub 1. If I plug in a 1, 5 times 1 is 5, minus 4 is 1, plus a sub n is 10. So if I plug in a 10, 50 minus 4 is 46. And then I divide by 2. I'm going to get 47 times 10 divided by 2 is the same thing as 47 times 5. So I'm going to get 235. By the way, when you go to evaluate these series, that is exactly what I want to see written on your paper. I want to see this. I want to know that you know what n is, that you know how to evaluate this sequence. You know how to plug the number in to get the 1. You know how to plug in the 10 to get the 46. I want to see this on your paper, so make sure that you're writing this down and that you're not doing it in your head. Okay, so be sure that you're actually doing this. Let me show you what the assignment looked like, because the assignment is actually kind of fun. All right, so you're going to go into your favorite place, right? Modules. I'm telling you, you guys are going to hate that word by the time May rolls around if you don't already. In today, you're going to go to where it says Pixel Art. Now, if you missed class today, Miss Taylor came in to talk to you about dual enrollment, just kind of FYI. This is the actual assignment for the pixel art. This is where you're going to submit a picture. You can take a screenshot of the pixel art if you want. But when you click on this, it's going to ask you to make a copy to put into your Google Drive. So put a copy of it in your Google Drive. And this pops up. So let's go ahead and do number 1 together. I'll probably actually do 1 and 2 with you before the video ends, okay? All right, so again, make sure that you're showing your work and you're putting your work on your paper, okay? So this is what number 1 looks like. This is number 2. I'm going to go ahead and do both of them with you. Your formula for today is this one, okay? this is the formula that we're going to be using. This is the formula that will evaluate this series. So here we go. If you take a look at number 1, there are 45 flipping terms in this sequence, and nobody wants to sit here with your calculator and type in 45 different numbers that you're trying to add together, right? So this formula is huge, huge help. Okay, so the formula says, right, we're going to do n. So this one has 45 terms, so 45 times. We're going to find the first term and then the last term. So we're going to find the first term. So if I plug in a 1, 3 times 1 is 3, plus 3 is 6. If I go plug in a 45, let's actually get my calculator for this, because who wants to figure that out? So 3 times 45 plus 3 is 138. And then I'm going to divide this by 2. Okay? Be really careful. I call it fat finger syndrome, right? So when you're adding things, sometimes your fingers might hit the wrong numbers. If you ever get the wrong answer, just double check. Make sure your numbers are right, but make sure you typed it in correctly, okay? All right, so I'm going to add those together. So 138 plus 6 is 144 times 45 divided by 2, and I should get 3,240. Now this is how the pixel art works. So you're going to go into the spreadsheet, and in this first box, we got an answer of 3,240, and as soon as I hit enter, watch what happens. See? Some of my little pixels showed up. All right, let's go do it again. So number 2. Same thing, right? We're going to do this formula. N this time is 8. I'm going to go plug in a 1. So 3 minus 9 is negative 6. When I plug in an 8, 3 minus 9 times 8 is going to be negative 69. I'm multiplying that by n, dividing by 2. So negative 69 plus negative 6, I can show you, right? Negative 75 times 8 divided by 2 gives me negative 300. Let's go into our pixel art. Keep our fingers crossed. Whoops, not 0.30. Negative 300. Keep your fingers crossed. Yes, more pixels showed up. Listen, that was it. Easy peasy. Everybody got it done in class. So hopefully you'll get it done in the next few minutes, okay? Send me an email if you have any questions.